Hello, everyone. This is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, Why Antenna Selection is Critical to Wireless Deployments, presented by Galtronics. Our presenters today are David Whitwer, PhD, CTO at Galtronics, and Ray Preston Hild, Vice President of North America Infrastructure at Galtronics. At this time, I'd like to pass the presentation over to David and Ray.
Hello, everybody. This is Ray Hild with Galtronics. First of all, thanks to everybody for taking their time today to dial in and to listen to the webinar. And with me is Dave Whitwer. Dave, as Kyle said, is our CTO and drives the engineering, R&D, and technology here for Galtronics. And what we'd like to do today is talk a little bit about antenna selection, the wireless deployment process. But first, I'd like to talk a little bit about the company, why we exist and what we do, and then turn it over to Dave from there. So Dave, next slide, please. So Galtronics has been in business now for over 35 years, and we have 5 design centers located around the world. We hold over 71 patents, and over those 35 plus years, we've learned how to make a wide variety of antenna solutions for a wide variety of customers. Today we'll be speaking about small cell, ODAS, and indoor DAS. Our value proposition is pretty simple. All of us on the call today always have to answer the question, why Galtronics? Or why your company? Why should people do business with you? And what is it that we have to offer that is a significant differentiator for the firm we happen to work for? From our point of view, there's really 6 tenets to that process. There's the most important one, which is integrity and trust. It's the existing relationships. It's doing what you say. It's partnering with your customers to solve problems. And overall, it's having a genuine interest in helping others be successful. Second part would be service. You need to have service locally, globally, and a fix-it-now type of mentality. You need to have the ability to have a large variety of product with great products and great partners. So when we look at the carrier process, we partner with the major carriers here in North America and around the world as well to make for sure that their requirements and their desires are built so that when the venues are deployed, the antennas being a part of that, those requirements are met. And we do a lot of joint development work with major OEMs that a lot of you would recognize around the world, whether it be in an embedded solution, an external solution, small cell type solutions. And to that end, in those 35 plus years, we feel we have the best product mix in the industry with a robust funnel moving forward. So products and partners are also important. When you look at pricing and availability, a lot of the DAS jobs, as we all know, those of us who have been in the business a while, all of a sudden budget is approved, they move forward to fruition, and then availability becomes a key issue. When can I get it? I need it yesterday. I got to have it tomorrow. To that end, we have a stocking logistics facility in Arizona. We partner with many of the named distributors around the United States. We have manufacturing in several different locations that we can ship from. And from a price perspective, the pricing is always competitive. So we feel comfortable in being able to get you the product when you need it. It will work at a price that makes sense. We're a public company based in Toronto, Canada, traded on the Canadian Exchange, so stable with 35 plus years of history. And the last point is that when we build product, we build from the customer back. So the 5 points that we're going to spend some time talking about today are listed here on the screen in front of you. So choosing antenna products. One size does not fit all. Each build is unique, and each building has its own particular characteristics. Each build also has its own capacity and its own coverage requirements. So it's real important to understand and to have a wide variety of options to target the in-building DAS capacity and coverage for that particular facility. Second bullet point, optimizing MIMO capacity. It can be done with antennas made for just that purpose. We were the first one to market with a MIMO antenna and have several offerings available today. And cross-polarization is a key factor here that Dave will speak to a little bit later on in the presentation. Number 3, A lot of the builds that we're seeing today compared to several years ago have more dense sectorization requirements. In these dense builds, creating the maximum amount of sectors will help the carrier achieve more capacity and obviously help the end user with better throughput on their individual mobile devices. Small cells. There's embedded solutions. There's external solutions from an antenna point of view. What options make sense? What are the pros and cons to each of those options? And maybe there's both. But the choices are critical to take advantage depending on the results that are desired for that particular build out. And lastly, what considerations need to be taken into fact when you're looking at an outdoor DAS build and you're trying to drive the maximum amount of peak performance out of that? And there's lots of them. Each ODAS build is also unique and requires a lot of careful planning to reach those desired outcomes. Next slide, Dave, and I'll turn it over to you.
Hello, everybody. Dave Whitwer here. I want to spend some time and talk about the first few bullet points, and also want to remind you that as we go through the slides, feel free to submit your questions via the questions panel, and we'll try to get those at the end. So let's get started. We want to talk about the first bullets about selecting antennas and what's important for an in-building DAS antenna. This slide was shown in a previous webinar we gave. It's a bit of an eye chart, and I apologize for that. But the one point I want to make here is that antennas are one-port devices, and oftentimes we have people approach us at trade shows and ask, what's the gain of the antenna? And while gain may certainly be important, antennas are more than just gain, right? It's not an amplifier per se. It's a distribution system. It's a way that power is distributed in space. So what I'm trying to point out on this slide is that the antenna directivity, which is how that power is spread through space, is at least as important, if not more important, than just the gain value. We want to keep that in mind, and I'll show you some examples of what the trade-offs are for that. But again, this is just to refresh ourselves on antennas, and gain is certainly an important metric, but it really represents how power is distributed through space. And when we're designing in-building systems, we're probably more interested in where the power is being put than necessarily what the absolute magnitude of it is. So antenna gain is great as an indicator for antenna performance, but really what we want to focus on is antenna directivity. And this is an example of that statement. So we've done benchmarking in the past that shows what the antenna patterns are for our products and our competitors' products. And on the left side of this upper left-hand side, you'll see a 3D plot of the measured antenna performance for one of our particular antennas. And you can see that it looks very symmetric. And that means that the power is uniformly distributed throughout space. And because this is an IsDAS antenna, we want that power to be distributed below the ceiling. So that's why it looks upside down in this figure. And when we compare that to some of the other products on the market, we see that those products may or not necessarily uniformly distribute power throughout space. And that might be a problem in your deployment when you're trying to meet your IB wave design criteria of neg 65 over 95% of the building floor space. So it's important to also look at the antenna patterns here. So at the bottom, you can see what happens when you have this directivity in the antenna pattern. It creates these differences in received power not being as uniform as you move around the coverage area. So the key point here that I want to have everybody keep in mind is that antennas distribute power in space, or I like to think of them as spatial filters, right? So I put 1 watt in, and the antenna dictates where that 1 watt is spread out. Is it spread out uniformly, or is it spread out in a particular direction? So when you have this idea in mind, and say you're working on a particular venue that you need to do a design for, there are a lot of antenna products on the market, and hopefully what I'm saying here today applies to all of the products on the market, not just ours. But when you have a choice between products, they're in different sizes, and those sizes generally correspond to some kind of pattern difference. So the antennas with larger ground planes, the antennas with larger ground planes have the ability to direct the power below the ceiling tile, and that's depicted in the figure in the lower left-hand corner. And this may be desirable from a performance perspective, but we all know that we have venue owners that are somewhat resistant to this difference in size. They want the smallest thing possible. They don't want to see it. So the point we're trying to make here is that a slightly larger ground plane will allow you to direct the power below the ceiling, and that provides the best possible performance that you can probably achieve in an in-building DAS application. The smaller antennas, they'll radiate more power above the ceiling tile, and one thing to be concerned about there is if there are any PIM sources or other ducting up there that might cause performance issues. But we also see that the gain values are rotated closer to the ceiling plane. So in cases where you have low ceilings, this may be the only option you have, and just need to make sure that you understand that how the antenna distributes power through space is different for these two types of antennas. So move on to the next slide. This slide is intended to you may be sitting there listening to this going, well, okay, venue owners want small antennas. Why not just give them small antennas? The last slide tries to make an argument that you don't want to give up performance just to satisfy the venue owners. So how do you do it? So you can maintain a larger antenna size in your design if you're able to conceal that antenna in some fashion. And we offer, as well as other folks in the market space, offer concealment options. And the ones that we find the most useful are a through ceiling mount. This slide shows the same antenna mounted with 3 different configurations. So you can see when the antenna is mounted through the ceiling, the visual impact of the antenna is reduced and the performance is actually maintained. The ceiling grid and ceiling tiles do not affect the performance as much as you might think. And because the power is directed below the ceiling with this large ground plane, that actually helps that antenna to be mounted above the ceiling. And then finally, on the right-hand side of this slide, you see a rendition of what the antenna looks like when it's mounting above the ceiling tile. So when you have the opportunity in your in-building DAS designs, if you have the space, it's better to include sort of these larger size antennas to get the best performance. And if the venue owners are resistant to that, look for concealment options before you just downgrade to sort of the smaller antenna sizes. This next slide is also a recap of some material we presented in a previous webinar. And the point we want to make here is, we're seeing more MIMO deployments today, but when we ask people about what they're working on and what they plan to deploy, we oftentimes hear that people aren't deploying MIMO because of the additional cost. And it seems a little surprising. We all see the news that goes out about carriers bidding on spectrum, and that spectrum is up in billions of dollars for carriers to purchase this. And when it comes time to actually roll out the venues and take advantage of the money already spent on the spectrum, we're kind of holding off because of tens of thousands of dollars or thousands of dollars extra cost in the deployment. So what can the antenna do to help this? We've developed a co-located cross-polarized MIMO that we presented the results of before. This is an effective way to deploy MIMO. We show that the capacity is very good. It's as good, if not better, than 2 spatially separated vertically polarized antennas. But the key takeaway here is that when you install one antenna instead of two, you're oftentimes the installation cost is determined by antenna count and how many locations you have to pull cable to. So this is a way for the antenna to help reduce the installation cost up front. Now, obviously there are other costs involved, and there's only so much we can do with the antenna to help those, but just keep in mind that using a single antenna with two polarizations may be a way to help reduce the installation cost for MIMO. Okay, so Ray's gonna talk now about what's been done for sectorization in high capacity venues, and Ray, I'll let you have it.
Thanks, Dave. And you had mentioned just a slide or two ago that gain can be important and is important, but performance is critical. There isn't really a better example out there that I'm aware of than the big game. And both of us were fortunate to be in a position to tour the facility a couple weeks prior to the game and saw the crews there finishing up, which was a massive deployment effort over a period of about 7 or 8 months. And what we saw here prior to the event was just an amazing coordinated effort and one of the most dense environments that I personally have been exposed to. This facility has a seating capacity of around 72,000 people. And if you do the quick math and you divide that by 48, you come up with 1,500 users per sector. Compared to just a couple years ago when it was 33 sectors for the same seating capacity. So this phenomenon, not just for this particular venue, but for most all venues, whether it be college football stadiums or Major League Baseball parks or high capacity convention centers, large venue environments where multiple people gather, there's a significant problem with getting the sectorization that is necessary to maximize the spectrum, as Dave just spoke to, at that particular venue, and to get the kind of soft handoffs that you need. So when we get up out of our chair and we go to the concession stand and we return to the chair, well, chances are we've walked through at least one, maybe 2 or 3 sectors. And if we're in a data session or on a phone call, it's necessary that the consistency of that call, that data session remain. And it's also necessary that you can hand off from one sector to the other as you travel around that particular convention center or football stadium. It creates quite an engineering challenge, and to see it firsthand was quite impressive. And there are reasons why they went to 48 sectors, based on the anticipated traffic that the carriers expected to see. This was led by a large major tower company here in the United States, and it was a true neutral host solution. So the considerations were multiplied. In addition to that, there's obviously macro surrounding this particular venue and a specific outdoor DAS system that was also built. And the roof can be closed or the roof could be open, depending on weather. So there was a lot of design considerations in the beginning here that were taken into consideration before construction even started. But when it came down to it, 48 sectors was required. The results that you see on the slide speak for themselves. As I recall, they were approximately double from the big game the year before. And there's no reason to think that next year it won't be even larger than that. The important takeaways on this slide is, in order to create the sectorization for high densification environments like this one, the beam width of the antennas are mission critical, because you must limit the interference between those sectors and point that RF light beam directly to where you need it, so you don't have overshoot. So if you're covering section 101 in the lower bowl with 1,500 people, you need to have the salt handoff between 101 and 103, and you have to direct the signal right to there. So our antennas, the 5777, the 5501, were the antennas of choice for this particular bowl. And Dave, if you could flip to the next slide, we'll talk a little bit more about the design and how they were deployed. So back in the day, not that long ago, 3 years, 5 years ago, I can remember stadiums of similar size where maybe 6 sectors or 9 sectors were okay. And I remember, and I'm sure many of you on the call do as well, designs that were more one-dimensional, meaning that you could just create the pie designs and not worry about separating the upper bowl and the lower bowl and the field and all those types of things. So that one-dimensional pie has gone away. It's now more of a 3-dimensional Rubik's Cube. And sectorization is much more important today, given the capacity requirements that we're all dealing with. So when you look at this particular bowl here, you'll see antennas mounted on the picture on the right in the catwalks. So there's always a compromise between what you're trying to achieve in the design and the ultimate commissioning process for capacity and coverage, and what the venue owner will allow. So it's very important that those options, or lack thereof, are established during a series of site walks and requirements gatherings, so you understand before the IV wave design is done what your options are and where you can place antennas and what types of antennas you want to use. Obviously, the better the performance of that antenna and the better the beam width, the more sectors that you can craft. And again, each stadium is unique. If we were to take a look perhaps at Fenway Park in Boston, and maybe compare that to Jacobs Field in Cleveland, and then compare that to Levi Stadium in San Francisco, no one stadium is the same. And in some ways, you almost feel like you're starting from scratch. The point of it all is when you have to divide any stadium into multiple levels, and then take into consideration the concourse area, the suite areas, the back office areas, many different coverage challenges are present, and each of these stadiums presents its own unique set of those challenges. Next slide, Dave. So here we zoomed in on just one sector of this particular bowl at the big game. And the pictures on the right, if you look closely, you can see how the antennas are mounted in order to achieve the sector boundaries that the carriers and this large tower company were trying to achieve. And the most important thing here is the mounting options and the tilt flexibility, the beam width of the antennas, so you can create the kind of sector boundaries that you're looking for, right? And having a space, a clear dividing line between the sectors so you have soft handoff. So what you see on the top is our 30 by 30 antenna. Those are used at the ends of each sector in order to create those sector boundaries. And then we infill, or in the middle, we put in the 60 by 30 antenna. And that creates that curtain wall of RF for that particular sector. And repeat as necessary across the particular bowl in order to separate each of these different colors on this chart to hit the sector boundaries that you're looking for. The narrower the beam width at the edge of each sector, the sharper the boundary that you'll have. The sharper the boundary that you have, the better chance you have for soft handoff. Next slide, Dave. So again, one size does not fit all. In this particular example we're speaking about now, there's some ODAS, there's macro, there's ISDAS in the owner suites in the back office, there's stadium antennas for the venue itself. It is more of a holistic wireless bubble that deals with a specific environment than it is one particular antenna. So the point is here is that choices are good. So it's not just about the antenna itself and the beam width, although that's a critical factor. It's also about the flexibility of what you can do with it, giving the places that you're allowed to mount them based on venue input. So we've developed some pretty creative mounting brackets, and there are others in the market as well that allows you to deal with some specific degrees and angularity of tilt and swivel so that you can direct that light beam specifically where you want it And then with the antenna, have that required beam width that you need to achieve your overall sector targets. From an antenna pattern point of view, as I mentioned just a moment ago, the narrower the beam width, the better in order to have consistent patterns. The one thing that you want to watch out for when you're looking at antennas is to make for sure your beam widths correspond with the sector counts you're trying to create. Number two is, as indicated on the slide, is make for sure that your side lobe and your front to back ratios are tight. You have good specs there. So the takeaway here is that sector boundaries are paramount when you're dealing with high dense environments like the big game, because then you have the ability to drive that capacity to the user so that you have the maximum reuse of spectrum, particularly in a MIMO environment. Next slide, Dave. There's a couple examples of some stadium antennas. Two of these were used in the big game, and there are more out there and more on the way. And I just wanted to bring this slide up just in case folks weren't familiar with them. The point of this is that whether it's Galtronics or anyone else, when working with an antenna OEM, make for sure that you have options and make for sure they understand and are partnering with you in the beginning of the process to understand where can I mount them, what are my challenges and pitfalls, what carriers am I trying to solve for, what are their sector requirements. And pay attention again to the site walk and requirements gathering process so that you can recommend the appropriate antennas into the design to achieve the throughput that you're looking for on the back end after the commissioning is done. Next slide, Dave, and I'm turning it back over to you.
Okay, thanks, Ray. So that's the high capacity venue discussion. So let's turn our focus now to small cells. So small cells are all the buzz these days as augmentation to DAS, and some people even claim a replacement for DAS. And they're consumer electronics type devices that are installed by less technical skills are required to install these things. And a lot of things that we see on the market have embedded antennas. Some have embedded antennas with the provisions for external antenna connections, and then some of them have just external antenna connections only. So the question is, how do you choose what antenna solution to use with whatever particular small cell you select? So a few of the trade-offs for the embedded solution is that when the antennas are actually integrated in the device, considerable amount of effort goes into providing as much omni coverage as possible. And the benefit of that is that the antennas themselves are not visible, they're integrated in the product, so it's a clean look and feel. But some of the things that you give up with that is that it's a little bit, the performance can be degraded, or I shouldn't say degraded, the performance is maybe not as good as if you were to use a larger external antenna, because the antennas have been made small to fit within the consumer electronics form factor. They may not be as efficient as a much larger external antenna. And then finally, the pattern that you get with embedded antennas, as I mentioned just a minute ago, is optimized to provide omni coverage. And that's great if you're looking for omni coverage, but if you're trying to cover a space that's a little bit more defined and you know ahead of time what that definition is, for example, if you're going to be deploying in ceilings, you're going to want a lot of the power below the ceiling. You won't want omni radiation patterns in that case. So the embedded solution is great for easy installation, and if you don't know where the thing's going, and omni coverage is maybe the best thing that you can do in that scenario. But if you're moving to like a more professional DAS kind of installation model, where you know ahead of time what your venue looks like and where you might actually mount the small cells and the antennas themselves, you might be able to do a little bit better by using larger external antennas. And the fact that the antenna is external from the small cell allows you to do things like place the small cells somewhere other than where the radiation is occurring from. So the small cell location can be independent, and what's shown in the figure is someone installing small cells above ceiling tiles, and presumably the antennas for that installation could be just installed in the ceiling, and it would appear to look like DASs look today. The opportunity to use multiple antennas is also maybe a little bit easier for the external connection, and you have more control over whether you use co-located cross-polarized or spatially separated antennas in that case. So in general, using the external antennas will allow you to have a bit better performance, and that may translate into maybe fewer small cells to cover a particular target coverage area. And then sort of on the trade-off side here is that if you do that, you obviously incur the cost of the external antennas as well as the jumper cables and so on. So small cell external antennas we think should be used in cases where you know what your target area coverage is, and if you're going to be doing a bit more of a professional install versus having like an IT department kind of roll out your small cell network. Okay, and now we jump from the small to the big, and just a few slides here commenting about some of the issues with outdoor DAS networks. As Ray mentioned in the beginning of the call, we develop products based on customer requests and needs, and one thing that we learned very early was that all customer needs are not the same. So, and in fact, if you're working with a nationwide customer, they may have different needs on the East Coast than they do on the West Coast, or even within municipalities within a particular region may allow certain antenna heights where others do not. So again, it's important to have a broad portfolio of products which allow all of the zoning issues to be addressed, as well as try to meet all of the RF performance requirements as well. So what would, go ahead.
So Dave, if I may, this is Ray. There's a large city in the Northeast with lots of boroughs, and it's not pictured here, but speaking of customer requirements, we were approached by a major tower company to come up with a whip type antenna, a 2-inch and a 4-inch whip, because at some point in time in this massive urban jungle, you run out of places to put things, zoning or otherwise. So it's important that the OEM, in this case us, be receptive and creative to those types of requirements and say, okay, well, if it's a 2-inch whip and it's got to be less than 48 inches high, it needs to have this many ports and handle these frequencies, how do we do this? So you sit down with the client and you build a requirements document and then a data sheet, and then you go into prototype, and we'll be launching whip antennas here fairly soon.
All right,
sorry,
exactly
Dave,
right. Yep. Okay, so let's talk about, we mentioned the requirement, the zoning requirements, and how different municipalities have different statutes that need to be complied with. And one thing we thought about was, well, how can we as antenna vendors help enable or ease some of this? And the thought is that if when you go to zoning, you generally submit the antenna dimensions and figures, and review committee will look at it and decide based on whatever their local laws are and sort of how they feel about the way it looks, whether that can be deployed in their city or not. And if you have need for different kinds of antennas to cover your area and not go outside of the area you're trying to cover and interfere with, say, an existing macro network, how can you ease that zoning process? And the idea is that if you think you're going to need multiple types of antennas to cover a particular region, It would be nice if you could go to the zoning board with one form factor and receive zoning approval for that form factor. And then once that's approved, you could use that form factor with different internal configurations to actually do your coverage. So the form factor is what's approved by the zoning board, but from an RF perspective, you may have different needs and requirements. So what we're showing here in the icons in the upper right-hand corner is the form factor is shown at the top of the screen, but within that canister, we're able to configure a full 3-sector solution, which is shown by the little icon, and then the bottom plate is shown below it from our data sheet. So you have all the connectors, 4 connectors per sector. We also offer a solution that has 2 sectors populated in this canister, and you might use that near an edge of coverage that you're trying to provide so you don't interfere with existing macro. A third configuration we offer is something we call back-to-back, and this may be useful in scenarios where you have hot streets and lots of traffic that you need to cover. And then also we offer a single sector version shown on the far right. And as just an example of how these might be used in a particular deployment, I live in Phoenix, and there's a particularly congested section of freeway at rush hour called the Broadway Curve. So I went to Google Maps and I extracted that and then defined a target coverage area that I would like to cover. And that's denoted by the red outline. And then I just used the mix of products here that are offered in the same form factor to illustrate how you might use them in different portions. Obviously, the trisectors are going to be used more towards the center of the target coverage area, but on the edges and perimeter of that, you might use the 2-sector or single sector versions so that you don't radiate power outside of your target coverage area and interfere with existing macro sites. And then the back-to-back solution obviously can be used along the roadway where the density is highest. So this is just an example of how we're trying to think about what our users are facing that are even outside the antenna space, things like zoning, and then ways that we can try and help that process by providing one antenna form factor so that only one zoning approval needs to be obtained. But still, the engineers have the design flexibility of effectively 4 different antennas. Okay, so this is the summary slide, and then we'll get to questions. But just to recap, we presented in the first part of the presentation some fundamentals about antennas and how antenna pattern or directivity is at least as important as gain, for sure, and that when you work on a particular venue, that different requirements may exist within the same venue even, where you need different types of antennas. So it's important to work with the supplier that can provide you a variety of different antenna form factors and antenna directivities. Secondly, we just refreshed everyone's memory that the operators are spending billions of dollars on spectrum, and one way to leverage the capacity of that spectrum is through the use of MIMO deployments, and that co-located cross-polarized antennas for MIMO deployments are effective, and it may result in some dollar savings. Ray presented some stadium example where a lot of capacity is needed during games and events, and he demonstrated that that capacity is provided through the addition of sectors, and that antenna beam width is a critical factor to look for when trying to enable these sectors, and particularly the sector boundaries. Next, we discussed some of the considerations when deploying small cells, whether to use, if you have a choice, whether to use the embedded antenna solution versus an external solution. And we believe that when external antenna connectors are available and something about the venue beforehand, and so the installation is a planned installation, that you consider using the external antennas to provide better coverage and it may result in fewer small cells being deployed. And then finally, we discussed outdoor DAS a little bit and talked about some of the issues there with zoning and permitting, and how a common form factor may ease the zoning portion of the design process, and then offering multiple antenna configurations within that single form factor design. So with that, we'll turn to the questions. And Kyle, if you wouldn't mind helping us out here.
Yeah, absolutely. Thanks, Dave. Great presentation. So yeah, we've had a number of questions that came in, so we'll just jump right in. So first one we got in, what other products does Galtronics manufacture other than DAS?
Oh, good question. This is Ray Hild. So in the 35, 38 years that we've been in business, if it is an antenna and it's needed to propagate something, there's a reasonable chance we've made it or do make it now. So a couple examples of that would be LMR whip antennas. We have a lot of tier 1 radio partners for public safety, public sector that require whip antennas for their radios. We showed a embedded small cell a couple slides back that is being deployed massively by one of the major carriers. Those embedded antennas inside of that small cell happen to be ours. When we look at other embedded solutions, whether it be routers for major manufacturers or a large cell phone manufacturer in South Korea that has a lot of notes and handsets and devices like that, you'll find our antennas in many of those. So that's what we do, is Galtronics makes antennas. That's what we focus on. And again, I can't emphasize it enough. The reason the antenna exists in the first place is because somebody wanted it, and they were willing to partner with us to build the requirements document. And then we work together through the prototype process to make it come to fruition, regardless of whether it's embedded, external, LMR, our new whip product, the new stadium offerings that are coming out soon. So yeah, if it's an antenna and you need it, we've probably made it. Good question.
Great. And another question dealing with your product set is, does mounting an IsDAS antenna above the ceiling impact performance?
Dave?
So we've done considerable testing of scenarios with the antenna mounted below, through, and above the ceiling. And what we see is about a 1 to 2% reduction in antenna efficiency. And surprisingly enough, the antenna directivity is actually directed more towards the floor. So overall, we don't see this as a significant difference in coverage. So I guess the short answer is no, mounting the antennas above the ceiling does not impact the performance. We have presentation materials on this, and we're happy to share it. If you'd like to contact Ray, we can discuss further.
Great, thanks. And following up,
Dave, to add to that, this is Ray Hill.
Go ahead, Ray. I'm sorry.
I'm sorry, Kyle. This is Ray. I just wanted to add Dave's response, and that is, if given a choice, if you have a venue like a 5-star hotel or a Class A office space, obviously there's a lot of aesthetically sensitive problems that we all run across in the industry, regardless of whether it's macro, small cell, ODAS, IDAS. It doesn't really, we all have similar issues. And the venue owners, certainly we have to respect and accommodate their aesthetic concerns. But to Dave's point, if you can get a larger backplane, and if you can drop it above the ceiling, and you only lose 1 or 2% compared to a smaller backplane, mid-mounted or below the ceiling, I would submit to the group here that it would make sense to seriously consider if you can get away with a larger backplane above the ceiling, because you may need less of them to get the kind of propagation and coverage that you're looking for. And if you can satisfy that IB wave design and hit the KPIs within it, and need less antennas, would that then lead to less passives? And could you sharpen your bid and maybe do a quality build with less cost.
Great, thanks. So another question we had. So earlier in the presentation, you pointed out the importance of gain. Um, do you also feel, how do you feel if about antenna propagating across all cardinal planes? Do you feel that's more important?
Okay, so I think the question is relative to the antenna slide. Just trying to flip back to that.
Slide 5, perhaps?
Yeah. Okay, so yes, gain is important, but as we stated, we believe directivity is at least as important, if not more important. And the word directivity means how power is spread throughout space. So I think the question is asking, um, I'm sorry, maybe you could repeat the question again. Trying to find it.
Yeah, no worries. Basically, it says you pointed out the importance of gain. Do you also, how important do you feel how an antenna propagates across all cardinal planes, vertical and horizontal?
Okay, so yeah, I think that what we're focused on by making this point is that we're worried about how the power is spread through space. Cardinal planes indicate, the XY plane, the YZ plane, and the XZ plane. I think a lot of the tools used today still use the concept of directive macro antennas, where two cardinal plane cuts through the antenna pattern pretty well describe its behavior. For in-building systems, particularly when we have lots of multipath, I'm not so sure, or I don't believe that simply two cuts or three cuts through an antenna pattern are sufficient anymore to describe antenna coverage. This is primarily due to the fact that, number one, the antennas are more omni or less directive than, say, a macro antenna, which means that their quote-unquote side lobe levels have a lot more variation. But moreover, that you have multipath in building, substantially more multipath in building than you do in a macro network. So I guess my short answer here is that I don't believe that even the cardinal planes alone are probably sufficient to do, accurate in-building planning. I would think the 3D patterns would be required.
And kind of a related question we had come in. For in-building environments, won't scattering help fill in for patterns that aren't a clean omni-azimuth pattern?
Yeah, so that's a great follow-up question, and the answer to that is absolutely. And as folks out there that are maybe evaluating antennas and buying antennas, the patterns that the antenna vendors provide to you are measured in anechoic environments. Okay, so they are without reflection. So when you mount these antennas in a building and you turn on the power and you do walk tests, you should expect to receive something different than what's on the antenna vendor's datasheet. And this is, in fact, exactly what happens, what this question asks. The nulls and the peaks are actually averaged over all of the multipath arrivals that the antenna sees. So yes, I think the answer to the question is yes.
Great. And Ray, we have a question for you. What antennas were deployed in the luxury boxes and specialty booths of the Glendale, Arizona Stadium?
Good question. Well, there were several. In the luxury boxes where aesthetics is most important, there's an antenna called the 5606, and I affectionately call it the frisbee antenna because it's SISO only, but yet it almost melts into the ceiling because of its slim form factor, and it can be painted to match as well. So that antenna was used a lot in that deployment.
Great. And we had a follow-up question with that, more opinion based. So, um, one of our audience members feel they will be seeing a number of small cells included in large capacity venues such as the Phoenix Stadium in order to maximize 4G spectral efficiency. Do you agree with that?
I'm sorry, Kyle, one more time?
Yeah, no worries. So one of our audience members thinks they will see a number of small cells included in large capacity venues in order to maximize 4G spectral efficiency. Do you agree with that?
If you look at the market today for small cells, at least in the initial launch of small cells, they tend to be tailored for particular carriers. Okay, so a small cell supports carrier A, and a different small cell supports carrier B. Um, until small cells are available that support all the carriers, like maybe you might call it a neutral host small cell. I'm not sure how effective it is to deploy small cells in large stadium venues because you would need a small cell at each location for every carrier, at least the way that things are constructed today.
Great. And we had another question come in about, large scale stadium type deployments. So how are stadium outlier customers dealt with, such as concession stand workers, individuals that are not exactly sitting and watching the game? Is there any difference to the access they have versus everyone else?
Well, let's talk about that one, Dave. This is Ray. If I understand the question directly, the concession workers and so forth, so that would consider them maybe back office.
Mm-hmm.
So if my perception is correct, in most of the large venues that I've seen done in my experience, back office is certainly part of the scope and the requirements gathering process. Now, if they're in a corridor environment or underground or in a high density environment that's indoor, you obviously aren't going to solve that necessarily with a panel stadium antenna, but you certainly would likely provide coverage and capacity to those areas. Perhaps not in the same type of capacity environment that you would in the bowl, but certainly would be typically included in most any DAS build, whether it be a stadium or maybe a large hotel property, 1,000 room plus, where you have back office, or even a hospital where you have, the bowels of the building as well. So a lot of times, the requirements from the carriers is going to be, 95 over 95. And that does include those concession workers and those back office employees. So hopefully I answered the question. Dave, anything to add?
Sounds good to me.
Thank you.
All right, great. So earlier when you talked about the embedded antenna example, how much ripple does the Omni pattern have?
Well, with the embedded antennas, from the picture, you can see that the antennas are mounted at the edges of the main PCB. And the reason for that is that the PCB and all of these shielding cans and everything actually create nulls in the pattern in the opposite direction. So I wouldn't consider this as ripple, but I would say that it probably creates blind spots when I mount an antenna in the upper left-hand corner, for example. That antenna will provide good coverage sort of in the area to the left and the area above, but obviously in the area to the bottom right, the coverage may not be as good. So with these embedded solutions, you see multiple antennas provided to supply coverage to every direction.
All right, thanks. Looks like we have time for just about two more questions. We had a lot of questions submitted today that we just won't have a chance to get to. Just want to let everyone in the audience know that both Dave and Ray will receive a copy of your questions in order to follow up farther. But our next question, how does the antenna selection impact pin performance, and does size actually matter?
So when we look at the antenna patterns that are shown for the larger diameter ground plane and the smaller diameter ground plane, you see that in the case of the larger diameter ground plane, less power is actually radiated above the ceiling. And because of that, if you have PIM sources in the plenum space, the area above the ceiling, an antenna with a larger ground plane would not excite those PIM sources as much as, say, the smaller form factor antenna shown on the right hand of this slide. This has actually been documented by Tom Bell and his PIM hunting work that he's been doing over many years. And he has a paper about that, and I'd like to refer you to that. But anytime that you can direct the radiated power away from PIM sources, it's beneficial.
All right, I think we have time for just one more question. So we had a number of questions, comments talking about, the future of DAS and saying, is DAS dead? So two-part question, do you feel DAS is dead currently? And do you expect small cells to eventually replace DAS?
This is Ray. No and no. And I'll explain again, personal opinion here. And we've heard comments recently to the contrary. So is DAS dead? No, I think when we look at maximizing spectral reuse and doing the best job that we can as an industry from the carrier out to provide the best user experience that's possible, we have to utilize all the technologies at hand. And that's where we're headed right now. It's not one thing. It's the whole deck of cards. It's everything that we have at our disposal that can be built together in a harmonious environment to enable the capacity and the coverage that the end user demands and that the carrier is trying to accomplish in a fashion that's most cost effective for all parties. None of us certainly wants to pay $500 a month on their cell phone bill and have coverage everywhere. So there's a happy medium that we have to meet. That's why it's called the HetNet. I personally believe there's not one dominant thing that's going to live or die. I think we all have to peacefully coexist together. And the second point to that is, I think, is as this industry changes from where we've been in the last 10 or 12 years, which is making a phone work in a building. If we think about it, go back 10 years, the reason that there was a BDA and coax was to make the CEO's executives BlackBerry work in his building, to where we are today, to where we're going to be in the next 5 years. It'll be a HetNet solution. What I think will change is the industry will learn to homogenize all the technologies that are out there for the betterment of the customer and the carrier. And secondly, what I hope we'll start to see is some intelligence built into these systems so that we can solve for location-based services and start to address on many forms the requirements from the FCC on E911. But more importantly, if we can homogenize these solutions and provide some intelligence on the system, we all have a chance to better monetize the system that we're all spending so much money on to build, which eventually gets passed on to the end user. So the point of all this is that if we can build systems in the future that can do more than just propagate RF, if we can add applications to them, if we can have a backbone that's sustainable, if you can tell where the device is or where the insulin pump is, or do tracking or maybe monitoring or all those kinds of things, that we can build that into the pull, then you only have to pull once to potentially enable many things. So is DAS dead? Is small cell taking over? Don't think so. I think it's all of the above, but I think intelligence is the way we need to go.
So I'll try and get the last word in on Ray. It's never been successful, but I'll try. So
I'll let you go today. You can have it today, Dave.
I think small cell is another tool in the toolbox. The cost of deployment of a DAS is not the same as the cost of deployment for small cell. But at the same time, a DAS is a neutral host deployment where a lot of common things are shared, common expenses are shared. When we look at the stadium solution, I think that's going to remain a DAS solution for a very long time. But we find places where DASs are maybe too expensive to deploy. Enterprise installations like hospitals or even some schools, you're not going to spend money on it, but a small cell may be able to handle it from a capacity standpoint more cost effectively. So I see DAS and small cell coexisting for
All right, great. I think that's a perfect place to stop the webinar. We're out of time, but I want to thank everyone for attending today's webinar, Why Antenna Selection is Critical to Wireless Deployments, presented by Galtronics. Again, our presenters today are David Whitwer, PhD, CTO at Galtronics, and Ray Preston Hill, Vice President of North America Infrastructure at Galtronics. Thank you to both of you.